Good day, teachers and learners. Good day, everyone. I am Teacher Tony, a junior high school mathematics teacher. In this video, we will explore on how we can use Classwiz calculator in learning and teaching geometric sequences. The examples and steps to be discussed in this presentation are also indicated in the Casio book on geometric sequences. The Casio emulator is a great tool for teachers to simulate the process of learning and computation in class. In this lesson, we will be exploring menu 1, which is the calculate mode, as we learn and teach geometric sequences. To start with, let us have this example number 1. In this example, we are asked to find the 12th term of the sequence defined by 1, 3, 9, 27, and so on. We can see that in this sequence, the first term is 1 and the common ratio is 3. Setting up the nth term of the geometric sequence, we have a sub n is equal to 1 times 3 raised to n minus 1. To get the 12th term using the Casio Classwiz, we need to key in the expression. Doing so, we have 1 times 3 raised to x minus 1. To calculate for the 12th term, we have to press calculate and then press 12 for the value of x, and pressing equals and another equals, we have the 12th term as 177,147. For this example, we are asked to find the value of the common ratio of the geometric sequence whose third term is 384 and whose 10th term is negative 3. Setting up the equation with the given conditions, we have 384 r raised to 7 equal to negative 3. Using our Casio Classwiz, we can solve for the value of r. Doing so, we have 384 using x as the variable for r, and then the exponent button, and then 7, arrow right, and then press alpha and then calculate for the equal symbol, and then negative 3. To solve for x, we need to press shift and calculate. We are asked by the calculator whether we want to solve for x. Press equals, and then we have the value of r as negative 1/2. For the last example, we are asked to give the geometric sequence of 5 terms if the first term is 2 and the last term is 512. With the given conditions, we need to set up the equation. We have the equation 2r to the 4th is equal to 512, since we need to multiply 4 common ratios to 2 to get the value of 512. To solve for the common ratio r, we need to use the polynomial equation function. To do so, press menu and then negative sign for the polynomial equation, and then press 2. Since the degree of the equation in our example is 4, so we need to press 4. We are asked for the numerical coefficients of the equation in general form. Thus, we need to transform first our equation in general form. We have 2r raised to the 4th minus 512 is equal to 0, thus giving us the leading coefficient be equal to 2. So press 2 and then equals. The third degree term is missing, so that is 0 and then equals. At the same time, the second degree is also missing, so that is 0. At the same time, the first degree term is also 0. The constant term is negative 512. Pressing equals, we have the first value of r as 4 and the second value is negative 4. Thus, in this case, there are 2 possible values for the common ratio, which are 4 and negative 4. Since we have two possible values for the common ratio, which are positive 4 and negative 4, we will be having two different geometric sequences of 5 terms. Setting up the nth term for these two possible sequences, we have a sub n is equal to 2 times positive or negative 4 raised to n minus 1. Let us use the table function to generate the first 5 terms of the two sequences. We have menu 9. For the first function, let us use the positive value for the common ratio. And so we have 2 times open parenthesis 4 close parenthesis raised to x minus 1. For the second function, let us use the negative value for the common ratio. So we have 2 times open parenthesis negative 4 close parenthesis raised to x minus 1. Press equals. Since we need to get the first 5 terms of the sequence, we will start with 1, end with 5, and with an increment of 1. Pressing equals, we have the first 5 terms of the geometric sequence with a positive 4 as the common ratio. We have 2, 8, 32, 128, and 512. For the geometric sequence with negative 4 as the common ratio, we have 2, negative 8, 32, negative 128, and 512. That's it for now. We are positive that our teachers will be able to share this learning experience to our students. We hope that we brought ease in teaching the remainder and factor theorem using our Casio Classwiz. See you on our next videos!